Welcome back, everyone. Next, we have Ideal Power. It trades on the NASDAQ under the symbol IPWR and is pioneering the development and commercialization of its broadly patented bidirectional semiconductor power switch, creating highly efficient and eco-friendly energy control solutions for electric vehicle charging, renewable energy, energy storage, UPS data center, solid state circuit breaker, and other industrial and military applications. Please welcome Dan Brdar, President and CEO, and Tim Burns, CFO. Welcome, gentlemen.
Thank you very much. Good to be here.
All right. Call me back when you're ready for questions.
All right. Well, we're excited to tell people about what's been going on at Ideal Power because 2023 has clearly been a pretty exciting year for us with a lot of things that I think are going to be of interest to the investment community. Start with a little bit of just some highlights. Our technology is called B-TRAN, and it's a disruptive semiconductor power switch that has some really compelling advantages over the conventional semiconductors that have been used out there. And it has a lot of markets that it really applies to, things like electric vehicles, energy storage, renewables, solid-state circuit breakers, motor drives, and many others, where it can bring a higher level of performance and really impact the economics of those applications by adoption of our technology. Earlier this year, we introduced our first commercial product, and we are really focusing now on commercializing our technology. The development phase for us is behind us, and it's now about customer engagement, getting product into people's hands, and starting to actually see the adoption of the technology and OEM products in a whole variety of markets. Our approach is a fabless model where it's asset light. We're really leveraging the huge investment that's already been made in the silicon wafer and silicon device processing infrastructure. And we spent the last couple of years figuring out how do we make our unique device in those existing silicon fabs. And we've got that well figured out. And we'll talk more about kind of where we are with rolling product out. We are currently engaged with a lot of customers that are in a whole variety of the key market segments, and we'll talk a little bit more about those market segments and what we're doing. We're in good shape financially. It's difficult markets out there for companies to be out there raising cash. We fortunately have cash that takes us well through the end of next year with no debt and a really heavily protected technology from a patent standpoint. We have 75 patents that have issued, another 35 pending. And we've been really focusing on execution against our milestones. We successfully completed all the milestones we laid out for the first half of the year, and we remain on track to achieve our milestones for the second half. And we'll take a little deeper dive into those a little bit later in the presentation. Let's start with just talking about what B-TRAN is. The picture on the right shows an example of a B-TRAN die. And if you were to flip it over, it looks exactly the same on the other side. It's a new semiconductor architecture. And part of what's unique about it is typically semiconductor devices are only fabricated on one side of the wafer. We're fabricating on both sides of the wafer. And that allows us to do something that results in a really compelling technology that is inherently bidirectional and also has much lower losses. So that means the OEM products that incorporate it can be smaller and have lower cost product designs because of the fact that the losses are much lower, there's less heat to dissipate, so there's less complex thermal management that's needed for the application. The performance of the product has been well documented. We've been shipping hundreds of devices now to customers that have even better performance than we promised. And it can really bring improvement to a whole variety of applications that incorporate it as a way to improve the economics of a whole variety of new products that will be coming out over the coming years. One of the things that is a significant change that we're seeing is the need to do bidirectional switching. And it's driven by the fact that batteries are now being used in a lot of applications. We see them obviously in electric vehicles. We see them in solar coupled with energy storage. We see bidirectional switching in standalone energy storage solutions, regenerative braking. And it's all about the ability to charge and discharge batteries, because you need to control the flow of energy and control the voltage and current in both directions when you're charging and discharging. Conventionally, high power applications have made bidirectional switches by putting together pairs of IGBTs and diodes to allow for the flow of energy or block it. that's had a pretty substantial loss associated with it. Conduction losses tend to be about 2.75 volts. In B-TRAN, we do the bidirectional switching all in one device. So one device takes the place of 4, and we can do it with 5 times better losses. So that means more kilowatt hours out of an energy storage installation or a solar plus storage installation. It means more miles for an electric vehicle. It can mean more faster charging for EV charging solutions. It's really all about dramatically impacting the losses that come from the semiconductors that permeate the products that are out there today. The markets where our technology really applies are the high power markets that today are served by IGBTs. That's the conventional semiconductor that's used. That market is expected to be about $11 billion by 2026 with a strong growth rate. And interestingly, it's really driven already by the adoption of electric vehicles and renewables. Those are already the 2 biggest segments that make up almost 40% of that market. But we also see it used in UPSs for data centers, for rail, motor drives, and a variety of industrial applications. And they're all looking for ways to how do they make their products more efficient, use less energy, and drive their costs down. If you look at electric vehicles, it's a large market. It's a $1.5 billion market for the semiconductor portion alone, because there's just an unbelievable amount of semiconductors in electric vehicles today. Where our technology applies the most is in things like the traction inverter, the battery charger, and some circuit protection that's on the vehicle. And those things actually make up the largest cost component of the semiconductors that are on the vehicle. So we're really targeting the segments where we can have a pretty high impact on the vehicle itself. When we think about our technology in electric vehicles have 2 big challenges today for adoption. One is their high cost. They're significantly higher cost than the conventional combustion-based engines that are out there. And there's still an issue with range anxiety. Customers are concerned that the range of the vehicles is less than what's advertised. The charging infrastructure is going to take many years to get built out. So range anxiety is an issue for many customers. Our technology can directly impact both of those. What a lot of people don't realize is the semiconductors are the second highest cost component in an electric vehicle. Batteries are the highest cost. Electric vehicles have such a high number of semiconductors that the semiconductors are the second biggest cost, and they make up 8 to 10% of the total vehicle. So a lot of money is really going towards semiconductors. The key really now is how can we bring the cost of the semiconductors in the vehicle down and improve the range at the same time? And that's really where our technology has a big impact. Because we are making our devices in silicon, in traditional silicon fabs, it's significantly lower cost than going through exotic materials like silicon carbide. And based on some work that Toyota had done, we've extrapolated the improvement in semiconductor performance if we applied it to our technology. And our technology could improve the range of the electric vehicle by 7 to 10% because of the improved conduction and switching losses. So it can bring the cost down and improve the range simultaneously, which is why we're seeing engagement from some of the world's largest automakers in our technology. A couple other key markets that we're targeting. One is obviously renewable energy, second biggest growth segment for power semiconductors. And it's really about how do you get more useful energy out of the sources like wind and solar, and particularly when it's coupled with energy storage. How do you make as much useful kilowatt hours for the customer as possible? So they're looking for better semiconductor solutions. Another key market for us is the data center market. In a data center, electricity is the largest operating cost, and all the electricity coming into a data center flows through the UPS systems. So the conduction losses of the semiconductors can have a pretty big impact on the operating cost of the data center. We did some work looking at if B-TRAN were used in the UPS systems, the average data center could save $2 million a year in electricity savings. So big impact on the economics of the data center. One of the markets where we're actually an enabler because of our performance is the solid state circuit market, circuit breaker market. Industry, utilities, and the military have been wanting to have solid state circuit breakers for a long time. They operate orders of magnitude faster, so they eliminate things like arcing and some of the maintenance associated with the contact wears for arcing. But the problem has been traditional semiconductors have too high conduction losses. We actually just completed a program that was funded by the US Navy for their ship electrification program, where we partnered with a company called Diversified Technologies, who has circuit breaker design experience, and focused on a B-TRAN enabled circuit breaker, 12 kilovolts, 500 amps, where the low conduction losses of the B-TRAN technology really enabled the circuit breaker application to be credible in terms of having much lower losses, less heat that has to be dissipated, allows the circuit breakers to be smaller because there's less thermal management that's needed. We completed all our deliveries under this program where we shipped them hundreds of tested devices. And interestingly, the interest in the circuit breakers and this project really has driven multiple Fortune Global 500 power management companies to come engage with us to evaluate our technology because they want to bring circuit breakers to the utility and the industrial markets. And it's a market that, because of the increasing electrification, is growing pretty rapidly. The circuit breaker market is expected to be over $9 billion by 2028, and having the ability to bring a fast-acting, low-loss design that's based on B-TRAN technology is drawing a lot of customers to start to engage with us on the technology. Our focus this year really has been all about the commercialization. So we are engaged with one of the world's largest automakers, where they are looking for a custom power module for their drivetrains that incorporates B-TRAN. We successfully completed phase 1 of that program, where we shipped them working devices and worked with the packaging company they've chosen. And as a result of the performance of those devices, we secured phase 2 of this multi-year development program. The objective is to have a production-ready B-TRAN-based drivetrain module by 2025. So pretty aggressive schedule for automakers. And in the interim, we're working with the industrial companies that are bringing products to the power control markets, to renewable energy, and to other industrial markets that can transact a lot faster than the automobile design cycles. We have engaged with a second one of the world's top 10 automakers, one of the top 10 suppliers to the solar power markets, 2 global Forbes Global 500 power management companies that are focusing on circuit breakers. And we're now starting to see tier 1 automotive suppliers engage with us also, as they want to look to use our technology for circuit protection and for the drivetrain. And also a global provider of backup power and energy management solutions for things like data centers. I mentioned earlier that we've completed all of the first half milestones. They included the introduction of our first commercial product. It's called the SymCool Power Module. It's a multi-die module really targeted for things like the solid-state circuit breaker market. That product has been designed, first builds have been done and tested, and it's targeted for commercial sale a little bit later this year. We completed phase 1 of the multi-year development program with a top 10 automaker, and we've secured phase 2 of that program. So we're excited to be continuing to build on the success there as we head towards incorporation into their EV drivetrain platforms, as using B-TRAN as a way to increase the range and reduce the cost of the vehicles. We completed a qualification with a high volume production fab earlier this year. So we have the ability to deliver high quality devices in volume to the customers that we're engaging with. And we'll actually qualify a second fab here a little bit later this year. So we've got plenty of ability to produce product for the customers that we're working with. We completed all our deliveries under the Navy program, where we shipped them hundreds of tested devices for the solid-state circuit breaker project. Later this year, we'll be introducing our second commercial product. It's called an intelligent power module. It's where we take the SymCool power module and add a driver to it. That's a product that's well suited for things like renewable energy, solar coupled with storage, wind generation, and some of the industrial applications that are out there that are typically buying modules for power conversion applications. And then we delivered all our customer samples under our test and evaluation program to all the large companies that have engaged with us. They received package working devices and a test kit. We'll be doing more of those because it's part of our ongoing process to keep engaging with customers and provide them samples of the technology that they can take into their engineering lab, test them, confirm the performance actually meets or exceeds what we promised. And so we're getting hardware in people's hands now, which really generates the excitement among their technical teams to start incorporating it into their product designs. I mentioned we have broad patent coverage. Our coverage geographically includes the US, Europe, China, Japan, South Korea, and India. And it covers a whole variety of things. The architecture itself, some of the control methodologies and techniques that we've developed, some things related to double-sided manufacturing, and some application-specific things that B-TRAN can be used for. And then we've treated the whole process of how we make this device in a traditional fab as a trade secret. So if companies want to study our patents, they'll still have no idea how to make the product. And getting through that validation of being able to make the product in a production fab was one of the key things that we've worked on here the last couple of years. So there's a lot of work somebody would have to do to figure out how do you actually make this unique double-sided device in the traditional semiconductor fab. If you look at just some of our recent news releases, they've really been around the things we're doing commercially, securing phase 2 of our development program with a top 10 automaker, our shipments to the customers participating in our test and evaluation program, qualification of our high volume wafer fab, tier 1 automotive suppliers engaging with us, introducing our first commercial product, and then entering this agreement with a global automaker for their EV platforms. So all news around commercialization and more of this to come as we do more and more customer engagement. As we were introduced, you were told we were listed on the NASDAQ, about 5.9 million shares outstanding. Cash balance, 12.7 million as of our last reporting in June. That gets us through 2024, no debt. So we're really well positioned to keep executing on this commercialization plan and really start to get hardware in people's hands. So with that, I'd like to open it up to questions that anybody in the audience has for us.
Great job, gentlemen, and congratulations. So let's talk about some future. What are some of the biggest revenue growth drivers looking out into the next, 6 months and into 2024?
Well, what's driving the adoption of really efficient semiconductors is the electrification of our society. We're seeing the adoption of electric vehicles, the need to build out EV charging stations, the adoption of renewable, the use of energy storage. So the macro trends in our society are really what's driving the adoption and are going to be the driver of our revenue here over the next several years.
I can see that. It's popping up all over the place, even where I live. So talk about markets and products. Which markets and products will contribute to this revenue growth the most over the next 24 months?
Yeah, what we're going to see is the industrial markets are going to be our early sources of revenue. People doing things like making solid state circuit breakers, people that are making power converters for solar coupled with energy storage, things that are being done for circuit protection. And then behind that will come the automotives, largely because of the fact that industrial products, things like power converters and circuit breakers have a much shorter design cycle than the automobile manufacturers. When they bring out a new vehicle platform, it takes 3 to 5 years to get through that whole process. So the next couple of years will be really the industrial markets that are going to drive our revenue as we ramp the business up. And then coming in right behind that will be the automakers that we're engaged with that will be buying in really large volumes to support their EV platforms.
And this is a pretty big market. So who are your competitors and what makes you stand out?
Well, the competitors out there are really the traditional semiconductor providers, people that are bringing the conventional IGBTs to the marketplace. The feedback that we're getting from the customers is our technology is not some marginal improvement. It's a step change. And that's really what customers are looking for, because improving efficiency gets harder and harder as the efficiency of an application gets higher and higher. So to have something that can significantly impact the efficiency and bring down the cost at the same time is really getting a lot of attention from some really large companies that people would recognize. And we hope to be able to start to name some of those before too long here.
Yeah, when might you be able to name some of those development partners?
We're asking the customers all the time. I think particularly on the automobile side, as we're getting deeper and deeper into this program, we'll be able to start to name who some of those automakers are or some of the tier ones, because it's when we look at the list of companies, it's pretty impressive. We think people would be pretty excited to see who the names of these companies are. We understand they want to protect so their competitors don't know what they're doing, but at some point they've got a far enough lead on their competitors. I think they'll be fine with us to start to name some of them.
And Rock Baker wants to know when he can get some estimates on pricing per unit and total revenues for 2024, 2025, and 2026.
Yeah, so for pricing, it's going to depend a lot on the product. Our initial product is a multi-die module, the SymCool power module. Typically, when you look at semiconductors, modules are a few $100s. So we haven't publicly issued pricing, but it's going to be in that ballpark. In terms of revenue, we're expecting that SymCool product revenue to start ramping in the second half of 2024. And the intelligent power module that we'll be launching here shortly is about 3 to 6 months behind that in terms of the revenue ramp. So as we get a little bit further along with some of these companies where we've delivered them devices already for their test and evaluation, get a little bit better handle on their design cycles and adoption cycles, we'll be able to provide some more specific guidance on revenue. But for now, we're expecting that revenue ramp in the second half of 24 for that initial product.
And that's really driven by the fact that for any new semiconductor, you have to get through a design cycle with the OEM to incorporate a new semiconductor and take advantage of all the benefits that it can bring.
Thank you for clarifying. Question from Corey Pankavaj. What's the cost difference between the newer silicon carbide competing devices and B-TRAN?
Oh, it's big. And I'll just give you a frame of reference to start with. If I go buy a silicon wafer today, it costs me about $60. If I want to go buy a silicon carbide wafer, it's about $800. And silicon carbide's harder to process. So, you saw this with Tesla a couple months ago where they came out and said, look, we're going to reduce the amount of silicon carbide in our vehicles because it's a cost problem. Silicon carbide will get cheaper over time. The quality of the wafers will get better over time, but it's a multi-year process. And for now, silicon carbide is really being used in the places where you have to have the ability to do higher temperature, or you have to have the ability to do higher voltage than what you can do with any silicon device, because the cost just really has to improve quite a bit.
A follow-up question from Corey asking, will the intelligent power module be to manage DC power, AC power, or both?
It can be used for either one. It's, that's the advantage of the technology. It can be used for AC or DC switching.
And Luke Copeland wants you to talk about your customers and reorders, especially the military as a customer.
Yeah, the military is great at helping advance technology. The program that we did was really part of the Navy's ship electrification program. So the Navy is really looking to change their ship design going forward, where they can start to incorporate batteries. They can start to rely less on the logistics and the cost of moving fuel around to support the Navy. It is a fairly long cycle for the Navy, which is why we're excited that we've got companies coming to us that want to do circuit breakers for the industrial and utility markets. But one of the final deliverables for the project that we did with Diversified Technologies was they were to deliver a whole family of products to the Navy of a variety of different sizes, so they can start to plan out their process for what size breakers they need for the various ships that they're going to go through that electrification process with. So I think we've got some great opportunity coming with them. It's just longer term, since they, like the automakers, have longer procurement cycles for the products they bring into their use.
And Aaron Villarreal wants you to talk a little bit about how you have two chips in one and this new cooling technology. Is there a patent on this?
Yeah, we've got a lot of patents. There's patents on the device architecture itself. There's patents on the packaging. There's patents on how we control them. So we've done a pretty comprehensive job, I think, of protecting the technology and the products. If somebody even knew how to make them, which nobody does at this point in time other than us and the fabs that we work with. So we're really making sure that, particularly as we're now bringing products out, the novel ideas that are going into the products for things like how they're packaged or how they're being cooled or controlled are also resulting in patents. And if you look in the last quarter, our number of pending patents increased by like 14 or 15, and they were ideas that were really driven by the products that we're bringing out.
And a product question from Nyasia Stout. Nyasia says, bidirectional switches. Would the alternative be two different switches, essentially saving the manufacturer's money? And what's the price of a bidirectional switch versus two single directional switches? You mentioned this earlier.
Yeah, traditionally for high power, like where our technology applies, they do use two separate switches. If you look at an IGBT module that incorporates a diode, they are a couple $100. If you're going to use two of those, all of a sudden, you're starting to talk, $400 for a bidirectional switch. If we can do that at dramatically lower cost, because we're all doing it all in one, you're getting improved performance and lower cost and a smaller footprint, which is also important as you start to think about, how big the drivetrain can be on a vehicle or how big the power converter can be on a solar installation. When you can start to shrink the size of the footprint of the semiconductors, the cost of the OEM product goes down because the enclosures are smaller, the heat surface is smaller. So it has multiple impacts in terms of how it's incorporated into a product.
And another product question from Caden Schmidt. Range anxiety is a big issue. So Caden wants to know, are you saying that your technology could reduce the price of EVs and extend the range?
Yes.
And how is this not globally adopted yet?
Well, it's not globally adopted yet, simply because we're just now commercializing the technology, but it's exactly why some of the world's largest automakers are working with us. It's why when we went into this program where we're doing a custom module, we had to go through a competition to get into that program. So we were competing against lots of other alternatives. So we think it's going to be a pretty well-known solution here as we get a little bit further along, because it really addresses some of the core issues that the EV makers are struggling with. Some of them will be quicker to adopt new technologies than others, but we think over time, particularly as we start to show thousands and thousands of hours of operation in these different technologies and applications, we think we ought to be a preferred solution for most of them. And candidly, they're all looking for ways to differentiate their platforms. So we're actually seeing companies that we would expect to be really conservative in the automobile space wanting to look at new technology like ours because they're looking for new solutions.
John Blankenship says, it seems you have a proven system. So he wants you to talk about your R&D costs. How much is R&D on your expenses? And do you see that continuing to increase or going down to improve margins?
Yeah, so it's a few $1 million in terms of R&D right now. So we're running about $1.5 million a quarter roughly in terms of R&D spend. As we look forward into 2024, it will increase. We'll continue to bring some people on the team, but our business model, as Dan had mentioned, is very asset light. So we really have a core technical team that works on the technology, a small front-end team for business development. And even if we are wildly successful, we will still have a small team because we're outsourcing the manufacturing and the packaging, really leveraging that existing silicon architecture. So while we will see an increase in, I don't know, maybe $1 million to $2 million here next year in R&D for the full year, our spending will remain pretty conservative because of our business model overall.
And Sean Evans wants you to talk about some of the automakers and Fortune 500 customers you have and in what quantity they're purchasing.
Well, right now we're in the process. We are providing them product for evaluation. The first commercial product, our SymCool product, is really targeted those Forbes Global 500 type customers that want to do solid state circuit breakers. That'll actually be available for sale a little bit later this year. So you're going to start to see the sales happening very modestly later this year. And then as they get through their design cycle of their own OEM products, you'll start to see that revenue ramp in the second half of 2024.
Yeah, the custom module program that we have, the target date, as Dan had mentioned, is 2025 for that module to be production ready. So from the EV side, it will be a couple years before you really start to see that revenue begin to ramp in that specific application.
And that's why we're excited the fact that our technology has such broad applicability, because we can really start to drive products and revenue on industrial applications like renewables and circuit breakers while we get through that longer process for the automakers.
And Hayden Kofi wants you to talk about your capital. You've got about 12 million in the bank, and can that get you close to cash flow positive, or do you have to go to the markets for more?
Yeah, so for us, we do have flexibility since we have enough cash to get us through 2024. Our view for capital has always been the same. It's to be opportunistic. You don't want to be raising capital when you need to raise capital. So we'll continue to keep an eye on the markets and what's happening there. But we feel pretty comfortable and pretty lucky that we had a successful raise here a few years ago, and really were able to fund operations again through at least the end of next year.
Perfect. Do you guys have any closing remarks for us today?
We just really thank everybody for joining us today, hearing about what we've been doing, and please keep an eye on our progress because we're putting out announcements now that are really all focused on things we're doing to commercialize products, engage with customers, and to ramp the business. So we think the rest of this year and certainly all of next year are going to be pretty exciting years for Ideal Power.
Well, congratulations on all this success, and we've enjoyed having you back on the conference and hope to see you again in the near future. Thank you, gentlemen.
Thank you very much.
Okay, everyone, stay with us. We'll be right back.